Alright, pre-calc. Today we are going to review circles. At least I hope it's a review for you guys. Should have seen these things for sure in Algebra 2. So, objectives for circles. We have 3 of them. Write the standard form. So we're going to look at standard form of a circle. We're going to look at graphing a circle by hand, graphing it using a graphing utility. So it's technically 2 objectives there. And then number 3, looking at the general form of a circle, which we didn't do a ton of in at least my Algebra 2. General form, we did a little bit of it. It's where we have to factor, complete the square to find the actual standard form of the circle. So we'll do a little bit of it. So we're going to get some factoring in today, which will be good. So objective 1, write the standard form of the equation of a circle. Okay, so first of all, let's look to see what the definition of a circle even is. So a circle is a set of all points in an xy plane that are fixed distance r, standing for radius, from a fixed point h, k. So notice that in our definition for a circle, h, k is the center. The fixed distance r is called the radius. The fixed point hk is called the center. So the standard form is written like this. This is when we have a center other than 0, 0, by the way, where we have x minus h squared plus y minus k squared is equal to the radius squared. Alright, so one of the theorems here that we're going to look at is what happens if the thing is centered at 0. Okay, so if we're at 0, 0, we don't worry about h and k because they just go to zeros, and we're just left with x squared plus y squared is equal to r squared. Another thing that we were very interested in pre-calc is this thing called the unit circle. Okay, the unit circle just states that from center of the circle to any, the distance from center to any place on that circle is just 1. It's called the unit circle, so the radius, no matter where it is, even if it's there, is a distance of 1 all the way around. Okay, we are very interested in this because we spent a lot of time later in this year looking at the unit circle when it comes to trigonometry. But we'll save that for another time. Example 1 says, write the standard form of an equation of a circle. Okay, so what we have to do here is remember that this is h, k, and this is r, right? So if we look at the standard form of equation of a circle, okay, which again, make sure you have that jotted down in your notes, is x minus h squared plus y minus k squared equals r squared. We're just going to plug in. Okay, so if we did x minus h squared, notice what happens. We have x minus a negative there, right? So it turns to positive, so it's going to be x plus 2 squared plus y minus 4 squared is equal to 3 squared, which we could write as 9. Right? So notice that's just what they got right here. They walk you through it in the solution. But I'm just plugging in my h, my k, and my r into the standard form of the equation of the circle. Okay. So let's look at another objective. It says to graph a circle by hand and by using a graphing utility. Okay, so for this guy, what I want you to notice here, you guys, is since it's technically x minus h, right? X minus h, and this turned to a positive, I know that h had to be a negative, right? So one of the things that I've always taught my students is when you're looking at these things, just consider this. What makes this go to 0? What makes this go to 0? That's your center. Okay, so what makes this go to 0 is negative 3, and this is the x value. And what makes this go to 0 is 2. Okay, that'll always work. So center is at negative 3, 2. And then notice that this is r squared, right? So r is equal to 4, because if we take the square root of 16, that gives me 4. Alright, so notice that 16 again can be written as 4 squared, r squared. Okay, So the radius is 4, right? Okay, so one of the things that I can do if I'm just graphing this by hand is I can just get my graph out, put the center at -3, 2, and then go a distance of 4 in all directions, right? So I can do a distance of 4 here, I can do a distance of 4 here, a distance of 4 over here, and a distance of 4 up here. So typically when I'm graphing by hand, I get those 4 points, and then I try to my best, the best that I can, if I don't have any other tools, to just kind of make this look circular through those points, right? And the better your graph is, I just drew this graph, but a lot of times you'll have like an actual graph for your tests and for your homework and stuff, so it'll show up even better, hopefully. So that's graphing by hand. Now, and they walk you through all of this. Okay, you can take a look at that if you want to. But let's look at graphing this thing with a graphing utility. So this is what I did here, right? And by the way, on your homework, on the online homework, you guys, they might have you come up with another, like some of these points that are on the line. So just be prepared for that. They might ask you for these points. You're just counting the distance of 4, right? -3 minus 4 gives you -7. In this x direction, if you're going in the y direction, we look at the y's, right? So we're going to go from 2 to 6 is 4, and 2 to -2 is 4. Anyway, and then they want us to do this by graphing on a graphing calculator. So remember, in order to do that, if you're on a calculator, you got to solve for y. This is, again, why I love Desmos so much. Because in Desmos, you do not need to solve for y, right? You don't have to solve for y in Desmos. So, but if you're using your calculator, you're definitely going to have to solve for y, and you get into some of this ugly algebra here. Okay, so they walk you through how to solve this for y. I'm not going to get into it too much here. Just remember, this is a term, so we subtract it. I'm trying to isolate the variable here, so we're going to take the square root of both sides. When we do that, since there was a variable in there, we have to consider the positive and the negative side of things. Then we're going to get y by itself by adding 2 to both sides, and they put the 2 out front. Anyway, once we do that, we want to graph both. We want to graph 2 plus that thing and 2 minus that thing. There's 2 answers here. Okay, it's 2 plus the square root of that thing, 2 minus the square root of that thing. And when we put those in, it'll show up as 2 different graphs, and there'll be this really weird hole here. Make sure of a couple of things when you guys go to do this, and we'll do some of this in class, is make sure you're using the square screen feature. So in your view, use the square view. And just notice that there's always going to be these disconnected points because of the pixelation of the calculator. All right, so we're going to keep cruising here. Example 3, finding the intercepts of a circle. So to find the intercepts of a circle, we can always do that by letting y equals 0. And then we can also let x equals 0, right? So if we want to find intercepts, we can just set those things to equal 0. So here, if we plug a 0 in here, notice what happens. That whole thing just goes to 1, right? So I'm just connecting it down here. They show you all the steps. And then I can solve this thing by subtracting 1 from both sides, right? So subtract 1, get 24. Okay, and then here, remember that with this, we can use the square root property. Okay, so I can take the square root of both sides, and I get plus or minus 24 because I took the square root of a variable, right? So x minus 2 equals plus or minus the square root of 24. Then they simplify the radical. So remember that if there's a perfect square within 24, so 24 can be rewritten as 4 times 6. This is a perfect square. So square root of 4 times the square root of 6 is just 2 square root of 6. I'm just showing you some of that. It should all be reviewed, but I'm showing it to you again here. Perfect. So we have 2 plus or minus this 2 square root of 6. That is for the x-intercepts. Now if we want to find the y-intercepts, what we're going to have to do is we're going to have to plug a 0 in for x. So the same method. Now we're plugging 0 in for x. Okay, remember that if -2 gets squared, it turns positive, right? A couple of reminders here. solve this, we get y plus 1 squared, sorry, is equal to 21. Take the square root of both sides, and just big thing that people always forget is when you take the square root of this guy, we have to consider the positive and the negative. So it'll be plus or minus. Okay. All right, so when we do that, they might have on the program, they might have you estimate this to the nearest hundredth like this, or they might have you leave it in radical form. I'm not sure what they do. But either way, just look carefully in your directions to figure out which version they want here. Okay, so if we're going to do this on a graphing calculator, it's a lot easier to find the intercepts because we can just do what we've already done, graph the thing, and then figure out where it crosses using our intercept function. All right, so that, just like we did with lines and curves and that kind of thing in a couple lessons previous, we can do that with a circle. Okay, so the last thing here is going into the general form of the equation of a circle. So for that, you might want to write this down. I think I have it in your notes. This is the general form of the equation of a circle. Okay, where you have x squared plus y squared plus ax plus by plus c is equal to 0. Always be equal to 0. That is the general form. Okay, so if they want you to graph something that has a general form like this, it's very difficult, and I don't know why we use it that often. There's a couple of good applications, I guess, but typically if we're trying to see what this circle is doing, it's not easy to identify looking at the general form. So what we like to do is we like to just put it back into standard form. So it's kind of funny, but that's what we do. So that's what they're going to do here. Okay, so if we're going to graph this, we're going to bring back some completing the square from Algebra 2 right now. Okay, so that's what they're going to do in this solution. But what I want you to do is I want you to group the x terms together, group the y terms together. Okay, so we'll do that in a different color here. And then always make sure that you move the any kind of whole number, non-variable term, constant term over to the right side. Okay, so that's what they did here, but I'm just going to take this to the next step. So they've just regrouped it is all they've done here, right? So I'm going to take it to the next step and show you how we used to do this where we complete the square. Completing the square involves taking half of the middle term, which is 3, and then squaring it. 3 squared is 9. So remember that when we do that, when we complete the square, we get this perfect square that's very easy to factor. Okay, so we get x squared plus 6x. So what I'm going to do is I'm going to add in a 9. But notice, guys, there's an equal sign here. If I add a 9 to one side of the scale, gotta add a 9 to the other side of the scale. Okay, so we're going to do that right now. Okay, added 9 into both sides. Okay, then I'm going to go to the y's. So plus, we have y squared plus half of 2 is 1. 1 squared is 1. So we have plus 2y plus 1. Okay. Okay, if I add 1 to this side, I have to add 1 to this side. All right. So, and if this is new to you guys, don't stress it too much. We'll do a little bit more in class. I'll answer questions as well. So this thing can be factored now. This thing can be factored now. And then this side can obviously be simplified. So when I go to factor that thing's going to factor to, it's always going to factor to the square root of this with this sign and the square root of this. So this is going to be x plus 3 squared plus y plus 1 squared is equal to, and I believe that is 12. Okay, let's see what they got. I think they got the same thing. Perfect. So they show you how to do that. Right, in example 4 there. Okay. Then they want you to graph it. So for this guy, it's a good idea to actually take the square root of 12 and like estimate that so we kind of know where that is. So if we go to graph that, we know a couple of things from what we just found now. Where are we at? So from this, I am able to tell I'm able to tell that the center is at whatever makes that go to 0. So -3, -1. And the radius is equal to the square root of 12, or approximately 3.5. Okay, so then they notice they put the point at -3, -1, draw a radius of 3.5-ish all the way around, and that's how you would graph it by hand. Okay, if you're going to do this on the calculator, we would solve for y first. Make sure you put in both equations, plus or minus. Make sure you're using the square root method to solve. And that's it for that. Now, I don't mind, again, if you use Desmos. In Desmos, you do not have to solve for y. Right? You can just plug it in just like it is. So Desmos is definitely the easier route to go, but get used to just try doing one on the TI if you have it. All right. For example 5, it says find the general equation of the circle. Okay, so if we're looking for a general equation of the circle, and we're given the center, and it says whose graph contains the point 4, -2. Okay, so if the graph contains this point, and we know the center, I can find the radius. Okay, now what I'm noticing here, you guys, this was nice of them, is that the y values are the same. So from center to this point over here, it's just going to be the difference in the x. So I know that that's 3, right? They did this whole distance formula, which you might need to do in your homework, right? You might need to find the distance between the 2 points. So they use the distance formula. But I could just count because, they made it easy for us. So once I know the radius and I know the center, I can write it in standard form, right? So I know that the center is 1, -2. I know that radius is 3. Therefore, I can write it as x minus, this is h, k, right? So x minus h squared plus y minus k, which turns positive squared, equals 3 squared, which is 9. Once I have that, I can put it into general form, you guys. All I have to do is move this 9 over here, but I'll wait to do that, and then factor these guys out. FOIL them out. So remember, they don't really give us a good example here, but x minus 1 squared is the same as x minus 1 times x minus 1. Remember your FOIL method. This is equal to x squared minus x plus 1, which is equal to x squared minus 2x plus 1. Okay, and then on the y's, we have, sorry that I'm writing over this stuff, but there's no room here. So y plus 2 times y plus 2. If I FOIL that out, I get y squared plus 2y plus 2y plus 4, which is equal to y squared plus 4y plus 4. Okay, so now we're going to put it all together. All right, and when I do that, I get, and I put it in general form. So x squared term first, y squared term second, and then a, b, c, 0. Okay, so let's do that. So we have x squared plus y squared, okay, minus 2x, x term's always first, plus 4y, okay. Then we have plus 5 equals 9. But I need to move that 9 over and set this to equal 0 if it's in general form. So if I do that, I subtract 9 from both sides, and I end up with this beautiful equation right here. And that is the last thing we're going to get into. I know that was kind of fast, and I know there's questions. That's okay. I'll make sure to answer those in class. Don't stress it, but do what you can. Start the homework, and we'll see you guys in class.